from session 5 and group 5. This is the engineering scientific group project with title regression. The project used linear regression method to determine the strength of relationship between the H and systolic of periodic movement. Present the task 4.2 A, B, and C. Use the Microsoft Excel as the simulator in this project because it's user-friendly and has the function to do the regression test. This is the data of our project. And from task 4.2a, you want to find the minimum, maximum, mean, and standard deviation of the data, of the data. And we use the analysis function in the Excel to get the result of this. From the scatter plot, we guess this is the linear graph, and the best fit line generated by the Excel is y equal to 0.895x plus 94.61. And this means it has the relationship between the H and systolic blood pressure. From this residual plot, we know that it is a group regression model because it fulfills the four assumptions. First, the residual variance are similar, residual are normally distribution, residual are independent each other, and this not any system of significant outlier.
Okay, 81046, question D. Ask to perform hypothesis testing to calculate whether linear correlation for the population at alpha equal to 0.01 and alpha equal to 0.05. So this is the hypothesis. So by using Microsoft Excel, this is the regression statistic. The number of sample views is 30. So the correlation coefficient R equal to 0.5409. So this is the ANOVA table. So the degree of freedom is 28. So for the test table, this is what we get from the Microsoft Excel. So by using formula, the t-test, the value we get by the calculation is 3.403, which is the same as we get in Microsoft Excel. So when the level of significance alpha equal to 0.05, so this is the value negative 2.064 and 2.064. So the hypothesis has been rejected at the 5% significant level in the age and systolic blood pressure hypothesis test. This provides sufficient evidence to infer that there is a substantial linear link between age and systolic blood pressure. So when the level of significance is alpha equal to 0.01, so the value is negative 2.763 and 2.763. So the hypothesis has been rejected at the 1% significant level in the age and systolic blood pressure hypothesis test. This provides sufficient evidence to infer the presence of a substantial linear link between age and systolic blood pressure. So for the conclusion, after testing with both level of significance, which is alpha equal to 0.05 and alpha equal to 0.01, the correlation for the population P significance is both rejected.
Then I will present about the test 4.2e. The coefficient of the determination R square is used to measure the proportion of the variant independent variable that is predictable from the independent variables x, and is ranked from 0 to 1, where 1 indicates a perfect fit. The Pearson correlation coefficient is used to measure the strength and the direction of the linear relationship between the two variables, ranging from -1, which is perfect negative, to 1, perfect positive. From the table on the left, we can know that the R square is equal to 0.29, and we can find the Pearson correlation by using the Pearson syntax and select the data in one of the area. And we can get the value of 0.54. And we should note that since the perfect value is 1, so the 0.29 is quite low. And since, we can say that it has a low relationship between the age and the systolic blood pressure. And then the outlier will cause the best fit line to distort from the overall trends, and hence lower the accuracy of the linear regression equation. And when we're looking at the table at the right, you can see that when the outlier is too far away from the overall trend, the best fit line will tend to move nearer to it and cause the distortion happen. And by using the data set, we can calculate the B0, beta 0, and the beta 1, and get a linear regression equation, which is y equal to 94.61 plus 0.8895x. Using that, we can use to predict the dependent variable. And test 4.2f, the regression model is suitable to predict the dependent variable. But if we refer to the table at the right, we can know that our dataset relationship is very weak, which is lower than half, 0.29. From that we can know that the strength of the relationship for our dataset of the group is weak, and hence we can say that the regression model is not suitable for the dataset of our group.